Madam, you may begin.
Okay. Hello students, good morning. In the last lab class, we have discussed about the YAC program, which is related to your first term up. And then with respect to second term up, that is implementation of the parser. I told you to implement LL1 parser, which is discussed in the theory part of the PD class. So in the today's class, we'll discuss about the Unix commands, implementation of the Unix commands, which is related to your fourth and then fifth term up. So Dr. U.P. Kulkarni sir is going to speak about the implementation of the Unix commands. Okay. Sir, you can take the session. Sir.
Okay, thank you, madam. Ashish and Arpita, are you online? Ashish and Arpita?
Yes, sir.
Yeah, that's good, right? Please look into, this is the continuation of whatever you people have learned in Introduction to Unix operating system, and now you need to develop a system called ls-l. We have picked ls-l. Part of those things already you people have done it, right, in bits and pieces, or gave a little short of whatever the professionalism that is expected, but you people have gone through. I'm going to give a finishing touch for that, and you are expected to do this term of number 4 in full length with what, okay, the highest level of quality, whatever that we expect, right? Let me get into the Unix system, right? You all people know about that. See, ls, and it has a different variations in that one options. One of that is ls minus l, right? You will be implementing similar to this, and you will be comparing your work with whatever the output you get it here. So the output should be exactly the same, including number of spaces, whatever you get in the output, including that it should be the same, right? So in place of ls, you'll be writing my ls, okay, dash l, right? This l is a command line argument. You all people know about that, right? So now let's look into that, what all the things we are expected to do, you know, but still it is my duty to tell here as a part of this term. Say when you do that one in a given directory, okay, there's a current directory, right? Whatever the files, folders, everything is there, it is going to display its attributes. Please look into that, right? So when you look at that, test 113 is the name of the file, right? Then you have October 2, 12, 27 is the timestamp of that, right? There are different timestamp, you all people know. I would like to address that. Then you have a size of the, okay, file in bytes. Then you have a username, group name and all. Then you have a number of links in that one. Then you have a protection, okay, whatever provisions are there for others, okay, for the owner, group and others, read, write, execute, okay, this. And then the first alphabet, whatever you see, that indicates whether it is an ordinary file, right, or it is a directory file, okay, or it is a link, okay. For example, look at this here, okay, in this case, right, 1 minute, I'll show you where it is gone. 1 minute, 1 minute. No, wait for that. Directory, yeah, okay, look at it, yeah, here, right? So you find that this is the link. The first alphabet either is a L, D or dash, right? Now my ls, my ls program, name of the program is my ls. My ls should work similar to what the output you are seeing here. That's the one thing, okay? Then one more important thing, probably recollect, okay, your submission part of that, only 1 or 2 people have done, remaining people are not done, right? The ls minus l command, okay, produces this total 19524. It may vary, right? What exactly is this? And you need to compute this and you need to display, and exactly like this you have to display, and that is what is the problem statement that you are expected to do in the term of number 4, emulation of basic command of Unix using system call. In this case, for this batch, it is the implementation of ls minus l command. Is that clear? Ashish and Arpita, is the
Yes, sir, yes.
yeah a problem statement? I made it very clear to you. Right now, let's look into that. The related programs, whatever that we people have gone through before, I'll share with you also. Right, the first one, right, in ls minus l, the first thing what I need is these attributes. These different attributes, where are they? Right, where do I get whether the given file is a directory file or the ordinary file, or right, a link? Right, how to create a link, that you should exercise, because you need to create a link and ensure that that link is appearing there. They're all the different test cases. Right, how to get the read write execute all these privileges? How do I get a like a link? Then name, username, group name, right? Okay, size of the file, the timestamp, there are different timestamp that we will get it. Where do I get it? And the name of the file, the first thing that we will see this. The second, okay, part of that is how do I navigate and try to get the list the directory contents. A directory content, for example, now consider that directory content is test 113. Now I need to look into, I need to sit in the loop and get all, okay, directory contents. Directory is nothing but a stream of information, right? That stream I need to capture, and for every, okay, structure, whatever I get it, I need to get the file name, check it whether it is a directory, link, or ordinary files, and accordingly get the different attributes, right, and then display, right, where all we get all these things. So we'll get into the first program is attribute of a given file, that's all. Second program is, right, listing this directory, sitting in a loop, navigating through the loop, and picking the content of the directory. When we merge these two, right, the ls program is ready. Right, let's look into the first program, attributes of the file. Right, you all people know about that. Right, I'll be using the command stat, lstat, and fstat. Right, stat, lstat, and fstat, and all these things, okay, uses a structure called struct right, struct stat, and this is, okay, available in stat.h, you can get into. Right, here I'm giving the path name of a file 0test.c, whose attribute I'm going to display. But what you people are doing is, you people, right, how to pass, okay, this file name from directory listing, whatever you do, pick that one, it is available as a variable, and on that you have to get the attribute and keep on displaying line by line. That's the one thing. Right, now, okay, look into this. I'll be using lstat. You should know the difference between the lstat, stat, and fstat. Right, lstat is being used, right, where, when. Stat is being used where, when. Right, so we will look into that. So like currently I'll be using lstat. Right, you call that one and provide a path name. Right, you have to construct a path name. Right, then the results of attributes of that particular file whose path name is given, right, is made available in the structure called struct stat. Right, what are its content, how do I get it? Right, we need to look into. Now here is an example. So when I execute lstat, uh, the structure struct stat contains all attributes. Right, one of that is a size, st underscore size. Right, try to get it and display. Right, the other thing is the mode. Right, the mode, st mode, okay, you need to, okay, do the some little bit of, okay, computations. Right, you and with these constants, when you and with these constant, you will get the read write execute permissions, whatever that is available as it is, and you will be displaying that one. Hope you should understand the depth of this, which already we have gone through in earlier class of the lower semester. Then there are three types of timestamp in this example I'm showing. One is C time, right? That is available, sorry, A time, right? Then M time, then C time, right? So what are these timestamp? These are the different timestamp which you'll be using, and you'll be using a C time as a system call to convert internal representation of the timestamp into human readable format, right? These are the few examples we are taking, right? Then number of links. Number of link is available in st_n link that you will be displaying it. Now here is an example, right? When you run it, you will get, this I'll show it, this kind of an output you get it. I was talking about the file permission 766. I hope you understand what exactly is this. 7 is okay, read write execute 4 2 1 4 plus 2 6 6 4 2 plus 2 plus 6 plus 1 7, that is read write execute permission, right? Second one is 6, it is a 4 plus 2 plus 0, right? It is a read write permission. The last one for read write permission for, right, group, right? First one is for the owner, second one is for the group, and third one is for the others. Others also have a 4 plus 2 plus 0, that is a read plus write plus no execute permission. You all people know about that, right? This is a kind of an output that you get it, right? We'll run it and see. Then look at the struct stat, whatever that we use. Struct stat speak about mode of the file serial number, inode number, right? Whatever we can use immediately, right? Then look at this here, number of hard link to the file. You can increase the number of hard link for the given file using ln system command. Then ensure that that information is made available in the listing, right? User ID, group ID, that information, right? Size, right? Timestamp. Okay, there are 3 different timestamp: A time, M time, and C time. A time is a time of last access, A for access, M for last data modification, right? C is for last, okay, status change. Creation time, usually whenever there is a change in the status of that particular file. Hope you understand the meaning of status now, right? This. And one more important thing which I'd like to tell you is the number of blocks allocated by an operating system, the block size, right, whatever it is there for this object. You have to keep on adding to all the files in the given directory, and then this value you have to compute, add it, and get it here. Wait, I'll show you. Yeah, see here. I was talking about the total 19524. What is that? Is the number of blocks used, right? There's that information you need to capture, add it from every file, every directory, every subdirectory, right? And then you have to display there number of blocks allocated for this object, right? Then block size. There is another information probably you need, right? A file system specific preferred IO block size for this object, leave it, right? So like this, there are whatever the useful information is there, use it. The remaining things, just leave it, right? So this is about the structure, right, which you people have gone through, right? Then you need to get into the C time system call, right? Are given the details here, and C time, right, converts, right, the internal representation into human readable format, and it will take the structure, right, this sta time, right, and is of the type sta time is of the type struct time specification. This is the built-in, right? There are 2 fields in that which you can get into time.h, right? There are 2 fields in that time specification structure. One is seconds, other one is nanoseconds, right? Yes. So we use number of seconds, convert that into human readable format. Okay, for that we use C time. C time function, look into that, converts the time pointed by a clock representing time in seconds since epoch. What is epoch? Epoch is something, a reference, it is something like a date of birth. So about your Kundali, Janma Kundali, whatever, whenever we talk about that, it is with reference to your, okay, date of birth, time of birth, okay, that is a starting point. So every product, Microsoft Word, Unix operating system, Oracle, you take any product, it has its own reference point. From that, it will calculate number of second lapsed. Got it? then that number of seconds elapsed since that time, birth time of that particular product is called epoch, right? That is being used, passed here, and it will convert into human readable format of the date, time, whatever month, year, time stamp, etc. Right? Thus, then there are three system calls: stat, lstat, and fstat. Please remember, uh, lstat is identical to stat, except that if the path is a symbolic link, then it returns information about that link and not the file what it refers to that. Hope you understand that, right? But fstat is identical to stat, except that file about which the information is to be retrieved is specified as a file descriptor. What is the meaning of that? So file descriptor, in the sense you have opened the file, and the file which is opened, its attribute you wanted, in that case you are going for the fstat, right? Lstat you are using if there are symbolic link, right? That is there. Fstat is a generic kind of things which lstat and fstat, are lstat and stat are one and the same, except the link information, whatever that is there, the lstat provides. You people should know about all these things when you get into, right? Then what? Yeah, right. Uh, okay, that's all. Then one more thing which I would like to mention about the when we were talking about the epoch, the Unix, right? Uh, Unix epoch, it always gives a time lapsed since midnight, right, of Thursday, 1st January 1970. From that point onwards till today, the number of second lapsed that it will provide, and C time will convert that into the human readable format, right? Probably this may be one important thing which you have to remember for the placement. We don't know what you are going to get during the placement, depends, right? So if at all you get into the Unix related aspects and all, right, context during the placement, and happens to be this epoch and all, if you know, that will, you will have a upper edge on all other people, right? At least you should know epoch, at least you should know. Probably you may not remember, right, the Thursday 1st January 1970, right, the midnight of that, but at least understand the meaning of an epoch. This, are you clear about that? Right? Ashish and Arpita,
Yes, sir.
I think
Yes, sir.
this is the second time I'm doing it. Once in when we were doing with the introduction to Unix operating system. Am I right, Ashish?
Yes, sir.
So please get into the depth of that. Remember, you can play better. That. So this is about that. Let me run this program and give a feeling that, all right, this is thing which you can do. CC, you know about that, right? Minus ATTR. You know what is, sorry, minus O, I'm sorry, right? ATTR. Then I wanted to compile 10-1. I'm sorry, this is the naming. I use it, right? File attributes dot save, right? Can you tell me that one in this minus O option? Why do I use minus O option? Ashish? Ashish, and other people, you can verify whether you know the answer or not, right? Minus O, why for this, Ashish? Ashish,
Sir, Ashish said
okay.
plus.
Arpita, you tell me, why minus O?
Uh,
Arpita,
got sir.
no, right. Now look at that, okay. It will create an executable file whose name is attr, right? It creates, if you don't give a minus O option here and the executable file name, it will create a.out. Every time you compile different programs, it will overwrite on the a.out. So it is a good practice for every C program, the equivalent, I mean, it's a executable separate file you create with the same name, not like what I'm doing here, right? Is it clear? Is it clear, Arpita? attr is a executable name of the executable file, right? If I don't give it, if the a.out it creates are compiled. Now I'll run this, right? attr instead of a.out, I'll be running attr. What's the meaning of ./ here? You should know about all these things. Now look into that. When you run this, the file attributes of a file, right? There's 0test.c, which is there in my folder, right? ./ this particular, I don't want to give it from the root, the complete part of the current folder, okay? Thus current folder from this size of the file 260 bytes, okay? Permission 766, you can read it, right? All this you can see, right? The timestamp, all these things, right? So C time is a creation time, we'll say, but whenever the status of that particular file changes, it will take that timestamp. Status of the file could be anything, okay? It could be size, right? Because of the content modifications, right? It could be the protection, okay? Whatever that you have, read, write, execute permission, whatever it is, right? Yes. So this is what a minimum the information we got it, right? But you are supposed to get the content all whatever that is required, right, for this later. Is it okay, Ashish?
Yes, sir.
Yeah, which you people already you have done all these things, but you have to do it in full length of implementing ls minus l. In full length, it should be similar to the ls command, whatever you see it in what I can say, the Unix operating system. And if anybody implement ls with all options, just 1 minute, I'll mute the mic, 1 minute. If anybody implement ls with all options, I'll tell you, I mean all options, right? I will give 10 out of 10 in my software engineering, okay, course. And probably, okay, I take a privilege of asking Vidya Hemadri madam also to give a full marks in her course, 10 out of 10 for those only. If you do all options,
Yes,
doing
sir. For
do,
lab, CD lab, sir.
yeah, full marks you get it. All options doing is not simple. But if anybody wanted to do, right, please register with Vidya Madri madam as well as me, right, and submit before the third eye. Right, we will give a full marks, 10 out of 10 in my course, software engineering, right? So that is a open, right, problem statement to all of you, right? So any question at this stage? Hope you should not have it. Yeah, right. Then we will, any question?
Any questions?
No, sir, no.
You should not have any question because already we have done once. Only thing is that assembling is the most important thing, right? And for God's sake, right? For God's sake, do not copy. For God's, I mean, please, okay, learn everything and try to assemble. Got it? Right? If you do everything on your own, that will build certain ability in you, what to search, where to search, right? Problem solving capabilities and all. You can refer the internet, you can reuse the code and all. I do agree, right? But build a logic, and your copying should be according to your design principles. Got it? I want to display this one. Is there any shortcut? Is there any system call? I want to display whether it is a directory or a regular file or a link file. The first alphabet of ls minus l, right? Please refer this, right? This one, directory. Look at this here. Is there any shortcut? Where do I get it? Search. Okay, there may be programs. Part of that you take it and build, put it in your design, okay, things. That is acceptable. Got it? Right. Now let's get into the second part before getting into any issues here.
No, sir.
Okay, right. Right. Now let's get into second part, that is the directory listing. And again, we will come back to this, right? The previous program, whatever you have seen is the file attribute. Given a file, it will display you the attribute. But directory is a collection of different files. It contains subdirectory, it contains ordinary files, right? It contains link files and all, and you need to display attribute of all these things. The first one is that you need to navigate the directory contents. Got it? A simple program. Let me get into the program and come back to you. Right. That directory contents are nothing but a stream. Right? I request all the people to mute their mic. Now look at this. Right? That stream is being represented, here. Right? You can see it here. Capital DIR is the directory stream, and D is a pointer to that. Right? And right, you will be performing certain operation on this stream. Right? And when you perform operation, this stream contain directory, subdirectory, right? It may contain ordinary file, it may contain you can say link file, device file, whatever it is, right? Their attributes you wanted it. So each one of that, you have to store it in a structure, right? It's called struct direct. Every entry in the stream that you will be storing in the struct direct, right? Again, structure we will see in detail. Now look at that. The stream you will open it, right, on current directory. It could be any directory path you can give it. Any valid path, if you give it, it will open that particular thing, and the stream is made available to you, right? Hope the people who have gone through the Java programming, they understand better the stream. Stream is nothing but the flow of information. The flow will go in appropriate predefined format, and that's what is the structure, right? So the predefined flow of information, whatever that is there, you make an attempt to read from that particular flow of information called directory stream and put it in predefined structure called dir, which is of the type struct direct. We'll see its structure. And when you reach to the end of this thing, you will get null, right? And we have not made this as a robust code, right? If the path is improper, right? If D is valid, then if not, what? That P error system call, you have to use it. Please go through that. If everything is all right, then I'll be displaying. Look at that pointer, pointer to the structure. How do you access? You all people know, you studied in your data structure. Data structure is the mother of everything. Please understand that. If you are good in data structure and algorithm, literally you can do anything and everything from kitchen room to the office room. But if you don't know the data structure and algorithm and your capability by birth, whatever you got it, of solving the problems, if these three, if you are good in that, you can rule the whole world. Whether it is a big data analytics, whether it is a machine learning, whether it is an operating system, they are all nothing in front of this. This is the basic capability. So the structure pointer to the structure, the field is in a D name, the directory name, then D, I number, right, is a unique number called inode number, of that file number, like this. We navigate through that until you go to the end of the stream, and once you go to the end of the stream, you close that and stop it, right? Now, the details of all these things you have to look into, right? So you need, in order to use the struct direct, you need direct.h, and by default in Unix system call, Unix system programming, types.h is mandatory, right? Then directory file is a record oriented file. Please remember, the moment you say record oriented file, what is the record content? The record content, please look into that. Record content is implementation dependent, right? Do not try to read the record content directly, right? but they contain essentially two things, a file name and inode number. It may contain more than that because it is a implementation dependent. Every Unix vendor, for example, it may be Ubuntu, okay, it may be Fedora, right? Each one may have their own additional contents in their structure, okay, this records oriented file, right? But for that reason, in order to make it uniform, right, they provide hope in the design principles. You understand two things. One is okay, policy, other one is mechanism, right? Open directory, read directory, close directory, rewind directory, these are all called policy. The policy is nothing but another simple example. Printf is a policy. But how do printf is being implemented internally, right? It may be different in different compilers. Here also, the open directory, read directory, close directory, rewind directory, they're all policy. Policy is an abstract thing, right? It will be uniform, it will be user interface, right? It will be uniform, okay, in all implementation of operating systems, Unix operating system. But the internal, okay, implementation of all these policies are called mechanism. Mechanism may be different. The policy, separating a policy from the mechanism, this is the design principle of an operating system. Are you getting it? Right? So look, the record content, okay, is okay, implementation dependent, right? So you need to look into that. So direct H is a header file that is required. Then in that, right, you have a D number, file serial number, and name of the file. You know about that. And D number is of the type INO underscore T. Okay, why do you use INO underscore T? INO underscore T is defined in types.h, right? Why? This enables portability. What do you mean by that? So when you open the types.h, probably INO underscore T may be a long int, right? Then I could have written a long int directly, assume that for the time being int, right? Int. And every data type has its own limitation of lower bound and upper bound. When I use int in place of INO underscore T, my program may work here, but the same program when I take in some other place, the program may not work because of the limitation. Not necessarily this, it may be other things. So what you will be doing is, types.h defines, right, whether the INO underscore T is of what type, primitive type of C language. Is it integer, long int, short int, what it is, right? So depending on the implementation, each implementer, the vendor, okay, the developer of the particular operating system, in their types.h, they will define this as a int, long int, short int, whatever it is. So my program uses that one here. Where it has gone, right? INO underscore T, and accordingly D underscore I number will receive that particular data type. This will enable portability of the code. Got it? INO underscore T for the file serial number defined in types.h, right? INO underscore T shall be defined as a unsigned integer type in types.h. If there is any variation which is implementation dependent, that accordingly it will be written in types.h. Accordingly, my program will take this one and get into. So my programs works everywhere. And please remember one more thing, right? Types.h header file contains important data type definitions. It is considered a good programming practice to use this definition instead of underlying basic type. I should not use unsigned integer here. The reason I told you, portability. By convention, all types names end with underscore T in Unix, right? You have a course called programming practices and all, something programming practices. Am I right? Madam Vidya Hemadri, madam, can you tell me what is the course programming practice something?
Principles of Programming Language.
Something.
PPL, Principles of Programming Language.
something, the course you have it, and in that course you are supposed to study all these things. Correct? Right? Is that clear? And the why we are going into this, the Unix is ocean, right? I don't want to. Now look at that another example which I would like to give, a ocean flavor. When I say that one, the character array, D name, is an array of unspecified size. But the number of bytes, okay, preceding the terminating null byte, please look, you have studied everything in C language, okay, will not exceed name underscore max, which is a constant defined in every operating system which has a compliance to POSIX standard. Now question is, what is POSIX standard? What are the definitions in that one? How do I get these constant, okay, refer it in manual? How do I get it programmatically, all these things, and accordingly ensure this, right? I need to look into that, right? So this is a small depth. In fact, I call it as a shallow, right? The learning, shallow learning. Just 1 minute, there is a call here. I'll take. Okay, I'm back here. Right. This is the depth. So whenever you do a program, whenever you study one page in the textbook, it's connectivity in depth. Hope you have studied a depth first search, breadth first search, right? Connecting that one to different courses, connecting that into the placement centric when you study, then it becomes a meaningful one, right? So when people talk about the POSIX standard, can you name few POSIX standard related things? Why do it is required? Right? Say for example, you create a child process, right? Number of child process that you can create. Okay, you open the file, number of file a given program can open maximum. There is a limitation on all that things. You cannot keep on creating a number of files. You cannot create, okay, as a part of a parallel programming, you cannot keep on creating a number of child process. There's a limitation, right? How do you know about that? Where are the constant defined? And your program, to make a program robust, for example, you create one child, you created second child, right? Okay, your program is creating different child, assume that. Then you have to check that one every time the number of child you have created count and check with the standard max child, right? And as long as less than that, you allow the program to create a fork or whatever that is there, and this one, if it reaches that one, okay, you don't allow the fork, okay, to be created. In fact, fork will fail on its own. You can count, and this is called how a robust code can be written. Robust, what is a robust? Strong. What do you mean by strong? Any nonsense input environment a program receive, it should sensibly react to that. And that's what is a robust code. It could be memory constraint, it could be processor constraint. 1 minute, I have again one more call. Wait.
Hello students, if the session ends, please join immediately via the same link. Arpita, is it clear?
Okay.
If the session ends, you have to join via the same link.
Yeah, okay.
Yes.
Until we complete, right? I think probably, I mean, 1 minute, 1 minute. This is the science of, right, self-learning, and this self-learning alone will help you in acquiring a knowledge. Okay, not sitting in the classroom and whenever a teacher tells, then only I'll learn. No, you have to sit in the classroom, try to know what you are expected to study, then get into the depth of that, and that is a placement preparation. And if you think that a placement preparation is only what happens in the classroom, then you are totally wrong, 100% wrong. Got it? So session is closing by another 5 minutes. After that, please join for this. I'll take another 10 minutes on the second term work, right? Any question at this stage? Any question at this stage? Whatever learning is happening here is nothing to do with LS minus L, but it is required. And that is what is the completeness of Sufficiency is one parameter of learning, completeness is another parameter. Sufficiency, no direct listing, no attributes, leave it, right? But completeness is you get into the POSIX standard, you get into different constant, you get into how to build a robust code, right? You get into epoch, what is epoch? Okay, get into that, right? You get into portability issue. Why do I use all definitions given by types.h? It makes my program a portable one. Got it? So when if at all you get in interview something, an occasion here, you can play better. You can play better. Remember it. That's why this term work is selected. And if you copy from somebody, all those who wish to copy, please report it to me. Okay? For you also, we'll give a marks and will not evaluate you. I'm telling you officially. Right? But we don't want to copy. We don't want you to copy, because learning doesn't happen. And you will find later in a placement, if you copy, you will find a problem. You may get a S grade by copying. You may get a S grade by copying, right? But you will not clear the examination, right? For scripted for placement. You may get S grade for the examination which we scripted here. But there is one more exam, and that is a true exam, placement. Got it? Understood? Ashish and Arpita, I want you to acknowledge,
Yes, sir.
right? And that's what we script, and that's what we aim for that. Got it? Right? Not remembering is a different thing, but not, okay, going through probably some other Unix which we have done it, and while teaching Unix operating system, such around 76 programs. Hope Govind will appreciate that also, because he was also taking, right now he's in my room also. That I may not remember, but the moment I pick it, I know everything what to do. If you ask me right now anything, question on Unix operating system, right, I may not remember immediately. Govind, I'm telling it to Govind, he's sitting in my room here. But okay, I will tell you within a minute or so. I know where to search, what to search, and that is a placement preparation. You revise Unix operating system and get into particularly threads and all, right? Particularly process conflicts and all, right? Particularly what kind of memory management that takes place in Unix operating system. What kind of processor management, not a generic one. Which operating system you use? Ubuntu. Can you tell me what kind of a memory management, okay, is being done that? If you say, I don't know, gone. You cannot say it was not there in the syllabus, gone. You cannot say that UP Kulkarni has not taught that, or Govind has not taught that. Sorry, who is UP Kulkarni? Who is Govind? They are nothing, right? Your knowledge, your preparation, your placement, right? Syllabus is not everything which will help you for the placement. Please remember, I'm telling you officially. That's why 4 years focus on that. Rest of your, okay, life you can enjoy a lot. Got it? So joy of learning Unix operating system is different. It is only the structure, it is only the pointer, it is only, hey, fantastic. You can know system calls, okay, libraries and all. How do internal it happens? Pointers and all, pointer structure and all is a Unix operating system. Got it? So I will be closing this, and you will be joining immediately after a minute break. And in the next session, I'll be taking only 5 minutes. Got it? Right.
Yes, sir.
Hope Arpita and Manoj, not Manoj, Ashish. Manoj
Yes,
is a
sir.
CR of third semester. Got it? Right? And please look into that. There are 60 participants here. We wanted more. Right? Yes. So I'll come to the end of this session. I'll close this.